Hello. Now, here we have two circles. That is, one circle, that is the bigger circle, has a radius of 4 centimeter, and the smaller circle has a radius of 2 centimeter. They touch each other. In between these two circles, there is another small circle which is green in color, which I have shown with a green color. And this line XY is a tangent to all the three circles. Okay, I have to find the radius of the small circle. So I have written the question here. XY is a tangent to the three circles of radius 4 centimeter units, 2 units, and a small circle between them. Find the radius of the small green colored circle. We have to find the radius of this small circle. Now let us see how to do it. Now see. So I just removed the shading so that the figure is quite clear. So now see, this is the point where this tangent is touching the circle. So this is called as a point of contact. Here this is also touching the circle at this point. This is also point of contact. So first we try to draw from the center of the circle. We draw a line segment joining the point of contact. So let us first draw the circle. So this is the center of the circle and this line is the radius touching the point of contact. Radius through the point of contact is perpendicular to the tangent. Therefore, this angle should be 90. So this angle is 90. Similarly, we try to draw the radius from the center to the point of contact. So this is the radius from the center to the point of contact. Again, through the point of contact, the radius is perpendicular to the tangent. So this angle should also be 90. Now let us join this center and draw a line parallel to this tangent passing through the center of the small circle. So it will be like this one. Now if you see this is parallel to this and this is perpendicular, this is also perpendicular, that means these two are also parallel. So opposite sides are parallel, this becomes a rectangle. I think I am very clear because opposite sides are parallel and all angles, this angle, both are 90. That means this is a rectangle. Now let us join this center to this center. Okay, if this is 90, this should also be 90 because it's a right angle, so this is 90. Now we join the centers. Now if we join the centers, because this angle is 90, we are getting a right angle triangle. Okay, now let us say the radius of the small circle is r. If this is r, this should also be r because it is parallel and opposite sides of a rectangle are equal. So this will be r. Yeah. Now this circle, the radius of this circle is 4 centimeters. So that means from this point to this point, the radius is length is 4 centimeter. That means from here to this point, it will be 4 minus r. So this will be 4 minus r. I think I am clear now. Okay. So this length from here to this point perpendicular, this length is 4 minus r. Now what about this side? Here this is the center of the circle and this is the radius. Therefore this should also be r. This is the center of the circle and this is the radius of this bigger circle. So it should be 4. Now this is 4. So that means this total length, that is the line segment joining the centers of these two circles must be 4 plus r. So that means this length is 4 plus r. Okay. Now let us try to start naming this triangle. So let us name the center of the circle as A. Let us write this point of contact as B. Let us write this as C. Take this point as D. And the center of this bigger circle, let us name it as E. So when you are seen here, ADE is a right angle triangle. Because it's a right angle triangle, we can apply Pythagoras theorem. Okay. So all that we have done so far, let me put it down in words. Okay. So what is that? Radius of the bigger circle is 4 units with center E. Then what we do, we talk about this radius circle. Radius of the other circle is 2 units with center M. Then we talk the radius of the smallest circle BR units with center A. So this is the smallest circle with radius R and with center A. Then what we did? From E, draw a perpendicular to the tangent through the point of contact. This is the perpendicular to the tangent to the point of contact. C is the point of contact, E is the center of the circle. So we have drawn a perpendicular from the center to the point of contact. Next, we have again from A, we are drawing a perpendicular to the tangent through the point of contact B. That means we are joining these 2 points. So through A, draw AD perpendicular to EC. Okay, this is EC. So if it is EC, so I am drawing this perpendicular to EC. So when we draw this, now if we have drawn this, so what are we getting? So A, B, C, D is a right triangle, rectangle, isn't it? So if this is a rectangle, so now the figure seems to be very clear what we have done, what you have drawn. I have shown you things. Now when I say that ADE is a right angle triangle, then we have to find the length of AD. So to find the length of AD, we try to use the Pythagoras theorem. So I said this is a rectangle. So let us see what is the property of the rectangle. Okay. So this is a figure. Now what is the properties of the rectangle? All angles are 90 degrees and opposite sides are parallel and equal. So that means this side and this side both are parallel and they are equal. Both are R. Similarly, AD and BC must be equal and both are parallel. Okay. So if you find the length of AD, that means you are finding the length of BC. So now let us try to use. So what is it? From this property, what do you say? AB is equal to CD and AD is equal to BC. So that's what we, because when I said this is a rectangle, so this is the conditions we get into. Now, ADE is a right triangle. So let us apply Pythagoras theorem to this. What is the Pythagoras is? That hypotenuse square is equal to sum of the squares of the other two sides. So we put it there as side square plus perpendicular square is equal to hypotenuse square. This is the hypotenuse. The longest side in a right triangle is called as the hypotenuse. And this is a perpendicular. And this is a side. So now let us substitute the values. AD, that is a side I do not know. Let us write it as AD. DE is the perpendicular. So DE square. And hypotenuse is AE. It is AE square. Now, let's put the values. AD we do not know. We write it as AD square. DE. DE I have written as 4 minus R. So write 4 minus R whole square plus AE is 4 plus R whole square. Yeah? So we have just substituted the values as per the figure. Now what is because that is by substituting the values. Now we are A minus B. This is A plus B. So let us use the identity. A minus B whole square is A square minus 2AB plus B square for this 4 minus R whole square. And we use the identity A plus B whole square, that is A square plus 2AB plus B square for R plus 4 plus R whole square. Okay. So when you use the identity, you see here AD square, this comes 4 square minus 2 into 4 into R plus R square. And this side it is plus it is. So 4 square plus 2 into 4 into R plus R square. Okay. So what happens? For AD square, 4 square is 16, 2 fours are 8R, 8R plus R square. Here it is 16 plus 8R plus R square. So 16, 16 both sides are same, so it cancels. R square cancels. So what is left out? AD square minus 8R is equal to 8R. AD square minus 8R is equal to 8R. Let us take this minus 8R to the right side. When you take it to the right, it becomes plus. So it will become AD square is equal to 8R plus 8R, that is 16R. Now this is AD square is 16R. So let us take the square root of both the sides. So AD square is equal to root of 16R. The square and the root, they cancel and it will be only AD. And this is root 16 is 4 and R does not have the power, so it remains in the root sign. So it will be AD is equal to 4 root R. AD, that is this length is 4 root R. That means BC is also 4 root R. So that means AD is equal to BC is equal to 4 root R. This is your first condition. Okay. Now we proceed, do the same process with this side triangle circle. Now let us see how it is. Now we try to draw a circle. So now I'm not going to explain this here. From the center of the circle, I've drawn a perpendicular. From the center of the small circle, I've drawn a perpendicular. Parallel to this tangent, I've drawn PA and joined the same. So here, since they are perpendicular, this is 90, this is 90, this is 90, and this is a right angle triangle. So what it is? So PNBA is a rectangle. This is a rectangle. So since this is a rectangle, so AB is equal to PN and PA is equal to NB. Opposite sides are parallel and equal, as you know the property. So now this triangle, that is APM, is a right triangle. So when this is a right angle triangle, we again apply our Pythagoras theorem. Pythagoras theorem is what? Side square plus perpendicular square is equal to hypotenuse square. So apply that. So this is side square plus perpendicular square is equal to hypotenuse square. Now let us see which has for this triangle, which has those sides. Side means PA square. Perpendicular means PM square. And hypotenuse means AM square. So now let's put the values. So PA square. So this, how this is PM? See, this is R. This radius of the circle is 2 centimeter. So this PM is 2 minus R. Now this side, the radius of the small circle is R. Radius of this next circle is 2. Therefore, that is this full length, that is M into A. M to A is 2 plus R. So that's what we are substituting these values in this. Once you substitute, again we use the identity A minus B whole square for this and A plus B whole square for this. So what happens? So it becomes PA square, 2 square minus 2 into R plus R square is equal to 2 square plus 2 into R plus R square. Now let us take the squares. So this is 4, 2 to the 4R plus R square, 4 plus 4R plus R square. 4 cancels, R square cancels. So PA square minus 4R is equal to 4R. Take this 4R on this side, it becomes 4R plus 4R. So PA is square is equal to 8R. Now PA square is equal to 8R. Let us take the square root of both sides. The square root of PA square is equal to square root of 8R. Square and root will cancel. So it will be only PA. And this 8 can be written as 4 2s are 8 into R. Now you know square root of 4 is 2. So you can write it as 2 into root 2R. So it takes PA is equal to 2 root 2R, root R. Okay. So now PA is also equal to NB. That means these two sides are equal to 2 root 2 into root R. Okay. Now we take another triangle. Now see the figure, next figure. Now I am going to consider this triangle. that is FME. Now, when you talk about this triangle, now this when this line which is joining the center to the point of contact, if we had if we had extended this, this will be perpendicular because radius is perpendicular to the tangent to the point of contact. Therefore, this angle is 90. Now we will consider this. Now, as I said, PB is equal to this. That means 4 root R from the first condition, and NB is equal to 2 root 2 into root R from the second condition. That means NC must be equal to FE. So that means NC is equal to FE. That means 2 root 2 into root R plus 4 root R. So root R is there. Let us take out common root R and you get 4 plus 2 root 2. That means FE is equal to this much. And this side is 2 centimeter is the radius of this smaller circle. And this length ME, radius of the small circle is 2 and radius of the bigger circle is 4. That means this total length becomes 6 centimeter. So that is how. So in triangle MFE, it's a right triangle. So apply Pythagoras theorem. Side square is equal to this. So that is MF square plus FE square is equal to ME square. Let's substitute the values. 2 square and FE is equal to 4 plus 2 root 2 into R square is equal to 6 square. Okay. So this is 4. 2 square is 4 plus 4 plus 2 root 2 whole square into R because root and square cancels and it is only R and square of 6 is 36. Let's bring this one this side. It becomes, so when we take this, it becomes 36 minus 4. 36 minus 4 is 32. Now let's bring this down here so that we get the radius of the small circle. So here we are using the identity a plus b whole square for this particular bracket. That is, and a plus b whole square, if we use it, it is 2, a is 4, b is 2 root 2. So therefore it is a square, that is 4 square plus 2 into 4 into 2 root 2. That is, this is a, this is b and 2 plus b square, that is 2 root 2 whole square. Now here let me see this, let me emphasize upon this. 2 root 2 whole square is 2 root 2 into 2 root 2. So when you are multiplying a irrational number, then see whole number should multiply with a whole number, that is 2 into 2, and root should multiply with root. So 2 into 2 is, okay, and root 2 into root. So root 2 into root 2 means root 2 square. That means root and 2 cancel and this will be only 2. So there you get 2 into 2 into 2. That is 2 into 2 into 2 is 8. So that means your form takes this way. That is 4 square is 16 plus 4 to the 8, 8 to the 16, 16 root 2 plus 8. So now that's it. So bring this down so that I have explained it against here. So it is 16 plus 16 root 2 plus 8. Now let's add these two numbers, 16 and 8, it becomes 24 and 24 plus 16 root 2. 16 into root 2 value I have taken as 1.4. Value of root 2 only one up to only one decimal place. So if you multiply this, you are getting 22.4. 32 divided by this total, this 24 plus 22.4 is 46.4. When you divide this, you get R is approximately equal to 0.69. So since we have taken approximate value of root 2, that's why we write here the radius is approximately equal to 0.69 units or it's 0.7. Okay, so that's how you find the radius of the small circle between or embedded between two large circles having a common tangent. Thank you for watching and stay tuned for more such problems. Before you leave, please make sure you click on the like button and the subscribe button. And yes, thank you.